So hi everyone. Today what we're going to do is we're doing rational functions again. Oh, that's functions, all right. And we looked at problems before where we saw something like 1 over x. And we said that if we divide by 0, we ended up with a vertical asymptote there. So vertical asymptote at x equals, x equals to 0. Because if I plugged in 0, we end up dividing by 0. And we also found that, hey, I have horizontal asymptotes too. And we have horizontal asymptote rules. We have 3 of them. Let me go ahead and draw these 3 rules. The 3 rules were, is the top bigger, top exponent bigger? Actually, though, yeah, let's do the top bigger, the same, or the bottom bigger. And what we were referring to is if the exponent on top is bigger, that means we had no horizontal asymptote. If they were the same, x squared plus 1 over 3x squared, let's do minus 1. We copy the front values. And the front values would have been 1 over 3. So my horizontal asymptote was just 1 over 3. Whatever the front number is, you just copy it. It's that simple. And then the third one is that if the bottom is bigger, x squared plus 1 over x cubed, our horizontal asymptote, hopefully you guys remember, is y is equal to 0. And the reason behind that is as x gets larger and larger and larger, it buries the top, right? It buries the top. And when you bury a number with a fraction, it goes to 0. So in this problem here, going back, we have 0 x's on top and 1 x on the bottom. This is a horizontal asymptote, y is equal to 0. Okay, so that's what we've been working on, talking about characteristics of a graph. In this case, horizontal asymptote at 0, vertical asymptote at 0 also. And then we could plug in a number like 1. 1 divided by 1 is positive 1. We're stuck on the upper right hand corner. 1 over negative 1, let's say negative 1 here. We're stuck at negative 1, we're stuck over here. So every graph that we learn in algebra, algebra 2, and precalculus, we have a set of tools to make graphing easier. Sure, you can plug in all the numbers in the world, 0, 1, 2, 3, 4, 5. But in the end, the goal is to graph these quickly. Do you have a cheat sheet to graph this graph? Now today, we have a new term, a new cheat sheet, and that's going to be called holes. And a hole is demonstrated by this simple fraction. If I say x plus 2 over x plus 2 x minus 3. So looking at this fraction, f of x is equal to x plus 2 over x plus 2x minus 3. Or if I write this in the multiplied out version, x plus 2 over x squared minus x minus 6. Okay, these are both the same number, same statement. My issue is looking here, you'll notice that x plus 2 and x plus 2 are the same exact factor. They're exactly the same thing. Now, what do we normally do with fractions if they're exactly the same? Okay, what do we do? Now, let me give you a side example. If I write 3 over 3 times 2, don't we normally divide those out, leaving me a 1 over 2? That's normally what we would do with these types of problems. And that's what I'm going to say here. That's what we're going to do here. And we're going to talk about what happens, the process by which I'm going to look at this. First things first, we normally say, hey, what's my vertical asymptotes? And previously, we would say my vertical asymptotes are x equals to negative 2 and positive 3. Because that's what would make the fractions on the bottom go to 0. Okay? So I'm going to go ahead and say that. Okay, cool. What's my horizontal asymptote? In this case, you see x on top and x squared on bottom. So you can see that the bottom is bigger. If the bottom is bigger, our horizontal asymptote, y is equal to 0. So we're on our way of graphing this. On top, we can make the top go to 0 pretty easily. The top, we could say, oh, there's a 0 at negative 2 when x equals to negative 2. But here's going to be a problem. I'm going to go ahead and graph this, and I'm going to ask you guys to check, do we have all these characteristics? Do we have two vertical asymptotes? Do we have a root at -2? Do we have a horizontal asymptote at 0? So let's go ahead and break out our decimals here. Oops. I'm going to graph the graph x plus 2. Oops, darn it. Why didn't I do that? X plus 2, parentheses divided by x squared minus x minus 6. Okay, and take a look at my graph on the right side. Do we have two vertical asymptotes? I only see one, but we're saying there's two. If I go ahead and graph the vertical asymptote that I see it as 3, so x equals to 3. All right, that's 3. That's my vertical asymptote. Do we have a horizontal asymptote? Y is equal to, we said 0. Yep. So both these are gonna work for us. I'm gonna change these to dotted lines. Okay, so you can see that we have vertical asymptotes and horizontal asymptotes here. Perfect. But the only vertical asymptotes we have is at 3. What happened to the -2? We also said that we had a root at -2. So looking here, my graph is saying that on my left, I should have a 0 over here. I don't have a 0. I also don't have a vertical asymptote there. So what happened? What happened is we missed the hole. And what happens, you want to take a look here. What happens is when we end up dividing it, we end up graphing an easier graph. The graph is 1 over x minus 3. Now, if we look at our graph from on our right, this is the graph of x minus 3. We have a vertical asymptote at 3. Vertical asymptote at 3. The x on the bottom is bigger than the top, so we have horizontal asymptote at 0. And we have no roots. So what happened to the x plus 2? The x plus 2 turned out to be a hole. So we have a hole at x equals to 2, -2. Now I want to show you on the graph here what happened at -2. So follow along. So here's x is 0, right? And if I get closer to -2, here's -1, and here's -2. You guys see the hole? You guys might have to squint, but you guys see that hole? The graph doesn't exist there. It's almost like a hole in your jeans or a hole in your shirt. All of a sudden, bloop, the hole starts, and this graph dies here. Why does it die? It's because the graph does not exist there. We said initially that we could not be -2. That's what we initially claimed. X can't be -2 because that would have been a vertical asymptote. But it's not a vertical asymptote because it divides the top factor out. And that's our idea of a hole. A hole happens when we divide out a common term. So a hole happens when factors divide out. And in this case, x plus 2 divided by x plus 2. These guys divided out, leaving us a hole at, darn it, x equals to -2. All right, now I want to bring up one more thing. The hole we said was at -2, right? But there's actually a y value there. Take a look here. Do you see how it says undefined? But we can figure out what that undefined value is by plugging in the hole. Now we plug in the hole. And 1 over -5 is equal to -0.2. And this looks like, take a look here, I'm going to go ahead and show you guys. As we get closer to -2, look at the y value, -2.1. negative 2.0, negative 2.007, oh, 07, negative 2.05, negative 2.04, negative 2.01, and undefined. So the y value here should have been negative 2, negative 0.2. And this is our next tool in graphing these problems. Oops, lost it. Sorry, iPad died. Oops, this is the wrong notes. Okay. So let's go ahead and talk about, so let's go ahead and talk about this again. What is a whole? A whole is when you divide out a factor. Let me give you another equation real quick. If I say x plus 4 over x plus 4 and x, let's do plus 1. That's my function. Can you guys spot the whole? It's probably going to be at negative 4. I'm going to say negative 4 is because that's when x isn't allowed to be. It can't be negative 4. And that's going to be our whole. Well, what's the y value of our whole? Once I simplify this, we end up having to graph 1 over x plus 1. Now, which is easier? X plus 4 divided by x plus 4 times x plus 1, or just x1 divided by x plus 1? This is our easier graph. So let's go ahead and start graphing this graph on the right. Vertical asymptote. Hopefully you guys can tell now. Vertical asymptote is negative 1. Oh my goodness, this looks so terrible. And negative 1. We have vertical asymptote. Horizontal asymptote here is going to be, the bomb is bigger, right? The bomb is bigger. So we're going to draw a vertical asymptote, horizontal asymptote here. Perfect. Now, I have one more thing I need to graph. We have any zeros? Nope, no zeros on top. And let's go back to our whole. We said at negative 4, negative 1, 2, 3, 4. Negative 4, there's going to be a hole here. Well, let's find out what that hole is. I'm going to now plug in negative 4 into my reduced version of the function. Why? Because didn't we say negative 4 doesn't work? You're right, it doesn't work for the original function, but on the reduced function, this is what negative 4 should look like. It should look like negative 3. And negative 1 over 3, which is about right here. So here's one thing I have already. I have a point that's not supposed to be there, but it is along the track of my original graph. So what am I doing is I am taking my whole, which I know negative 4 is not supposed to work for my original problem, but once I plug it into my reduced version, I can see what should it have looked like. So let me ask you this question. If I say 10 divided by 5, is that any different than 2? Is 10 divided by 5 any different than 2? Well, 5 times 2 is 10, and isn't 5 divided by 5 just 2? Oh, 5 divided by 5 is 1, leaving me just a 2. So in basic numbers with constants, this is a completely true. What we're doing here is we're saying exactly the same thing, except is 1 over x plus 1 really the same as x plus 4 over x plus 4 x plus 1? Are these really the same thing? And the answer is 99.9% yes. But remember what numbers we're not allowed to use here. We're not allowed to use negative 4 and negative 1. Negative 1 is still here. We can't use negative 1. But we can't use negative 4 either. If these are equivalent, you're not allowed. Also, don't use negative 4. And that's a hole for us. So on the graph where it's negative 4, we actually draw a hole, a hollow point. On the right side, what would it look like on the right? Pick a point, 0, 1, 2, or 3 to plug into the equation. You can plug them all in. If I plug in x is 0, 1 divided by 0 plus 1, 1 divided by 0 plus 1 is 1, right here. If I plug in 1 over 1 plus 1 is 2, 1 over 2. 1 over plug in 2. 2 plus 1 is 3. 3. And we end up with a term that looks like that. So the way we figure out how to graph these is, one, we look for our asymptotes, our vertical, horizontal. Then we go ahead and plot our zeros if we have any zeros on top. Follow that with any holes that we need to graph. How do you find the hole? You first find the x value that cancels out. Then you plug it into your new reduced version of the equation, and that gives you your y value. Our hole is at -4, -1/3. Okay, let's do one more problem like this. If I say f of x is equal to x plus 2, x minus 2 over x minus 4, x minus 2. Okay? This could also have been written as x squared minus 4 over x squared minus 6x plus 8. Okay. Which one is easier to graph? Definitely the factored version. So on your homework this weekend, you guys will be doing two things. You guys will be seeing problems that are already factored, and then problems that you have to factor yourself. So those will be the two types of problems that you'll see. So if they're not factored, you will want to factor it, looking for vertical asymptotes, looking for holes, looking for zeros. And we'll practice that in just a little bit. On my left side, let's go take a look. Does anything divide out? The x plus 2 and x plus 2, right? So this graph can be graphed instead as x plus 2 over x minus 4 with a hole at x equals to 2. Right? Because if I plug in 2, that's our hole. Let's go ahead and start graphing this graph. What's my vertical asymptote? What's my horizontal asymptote? Can you guys spot those pretty easily? The vertical asymptote is at x equals to 4. The horizontal asymptote, remember these are the same speed. So that's going to be y is equal to 1. Do we have any zeros? Do we have any roots? Well, that's the top. Does the top ever become 0? Yeah, when x equals to -2. So we have a lot of things we can draw already. So let's go start drawing this. Our vertical asymptote is at 4. 1, 2, 3, 4. Dot, 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 dot at 4. Our horizontal asymptote is at 1. Y is 1. 1. We know we have for sure a root at -2. -1, -2. -1, -2. And we want to draw one more thing. That's find our hole. If we say the hole happens at x equals to 2, we plug it back in. To figure out what is the y value. So 2 plus 2 over 2 minus 4 is 4 over -2, which is -2. So our hole is at 2, -2. All right, let's find 2, -2. Where's 2, -2? Here's 2, -2 comes down right here, and you're going to draw a big fat hole, meaning a hollow circle. Now I want you guys to take a look here. The graph is probably going to be up here and down here, and if we look at my 2 points that we did draw, from point to point, this is what the graph would look like. Okay, on my left side. And we did go through those 2 points that were given. We went through our root at -2. We also went through our hole at 2, -2. How about on the right side? Is the graph going to be on the bottom or on top? Let's go ahead and plug in a number. If we said this is 4, let's plug in 5. 5 is easy to plug in. 5 plus 2 over 5 minus 4. That's 7 over 1. 7. 1, 2, 3, 4, 5, 6. We're up here. So we're going to be stuck on the top of this graph right here. And that's how we end up graphing rational functions. So these are the main characteristics that we have to work on looking for. We look for our vertical asymptotes or horizontal asymptotes. We've been working on that. If we have any roots, make the top go to 0. Oh, let's do one more. What's the y-intercept? If I can plug in 0 to the problem, 0 and 0. So if x is 0, our y-intercept, if x equals to 0, 0 and 0, we're left with 2 over negative 4. Y is equal to 2 over negative 4, which is negative 1/2. And look, at 0, this kind of does look like 1/2. Ish, right? Something close. It was probably a little better up here. All right, so let's go ahead and take a look at your homework today. Okay, here is our work for today. First question is, looking at this problem, are there any holes? All right, are there any holes? So we agree that stuff divides out. Okay, what divides out? We divide out at x minus 34. Okay, so x minus 34. Let me go ahead and try this. So you see x plus 34, and x plus 34. We divide out these problems. Perfect, great. So will this be a hole? Yeah, that's a hole for us right now. If we rewrite the problem, we have x plus 34 over x plus 80 and x minus 75. What are our vertical asymptotes? Looking at the bottom, we have negative 80 and positive 75. Is x being negative 34 a vertical asymptote? In this case, no. It's no longer, take a look here, it's no longer on the denominator. So we have a couple of vertical asymptotes for this. Let's take a look. My vertical asymptotes are negative 80 and 75, and our hole happens at negative 34. Our next problem here, I want you to see if you guys can visually do it. What divides out automatically? Hopefully you guys can see the x minus 2 divides out. So do we still have an x minus 2 in my simplified version? No. So that's our hole. What are the leftover factors on the denominator? We have x minus 26 and x plus 73. These zeros are going to be 26 and 73, negative 73. And those are the vertical asymptotes. If I ask you for what's a 0, the only 0 left is negative 34 on top. Okay. Looking at this next problem, what divides out? Darn it. Oh, come on. Okay, what divides out? What divides out is the x minus 8, x minus 8. Perfect. So our hole here is going to be at 8. How about vertical asymptote? It's when the denominator is equal to 0. So when we reduce, we have f of x equals to x plus 7 over x minus 10. Take a look. The only denominator that we're not allowed to have is when x is positive 10. So x can't be 10. That's my vertical asymptote. And you guys are going to be practicing this. Take a look at this problem here. Does anything divide out? X minus 6, x minus x plus 6, and then x minus 9 on top. Nothing divides out, so please write D and E. There are no holes, but there are two vertical asymptotes. And vertical asymptotes are 6 and negative 6. Okay, let's move on to the next type of question here. Is this problem here. What if I don't factor it for you? Now you have to work on factoring it yourself. Hopefully we're better at factoring binomials. What are two numbers that multiply to become 27 that add up to 12? Two numbers that multiply to 27 that add up to 12, that's 9 and 3. X plus 9, x plus 3. On the bottom, numbers that multiply to become 27 that subtract to become 4. That's 7 and 3. And we're going to say it's going to be a minus 7 and plus 3. Now you can see that we have a hole here at negative 3. When the x's divide out, x plus 3, those divide out, we are left with x plus 9 over x minus 7. Hole at x equals to negative 3. Vertical asymptote, though, at 7. Okay, let's move on to this next type of question. So this is written out in, this one is meant to be a little bit tricky, and it's supposed to demonstrate something. If I look at this, does anything divide out? The 7 and one of the 7's divide out. The 9's and the 9 divide out, leaving me x plus 1 over x minus 7, x minus 1. Now, this is a somewhat tricky question. Do we still have any holes left? Didn't we divide out the x minus 7? We did. But I want you to realize that we are still left with one more on the bottom. And what is a bigger issue, a hole or a vertical asymptote? The vertical asymptote. So it turns out we don't have any holes because that hole, which looked like a hole, right, was actually back to a vertical asymptote because there's more than one of them on the denominator. So on the graph, you'll see that this isn't a hole at 7, it's just a vertical asymptote, and vertical asymptotes take precedence over holes. What other vertical asymptote do we have? We have a hole at 1. 1 minus 1 is 0. Okay, so we have a vertical asymptote at 7 and 1, and we have no holes. Even though it looked like a hole, but because we had more of those factors on the denominator, we don't have a hole there. Let's see if the same problem on our next question here. Take a look. Same problem. We have a x minus 7, x minus 7. So you would think these would divide out, but nope. There's still one extra on the bottom. On top and bottom, these divide out, great. And we're still left with x minus 9 and x plus 4. So looking at my leftover equation, my reduced equation, what are my vertical asymptotes from it? We're not allowed to use 7 or negative 4. While we still have a hole at positive 3. Oh, darn it, I made a mistake on the last one. I forgot to say 9 is my hole. Darn it, I always forget this one. So 7 is not a hole anymore, but we still have 9. So darn it, sorry about that, guys. And when they want a point, I need to go ahead and talk about when they use the word point, that's an x and a y value. So when I rewrote the problem as x plus 1 over x minus 7, x minus 1, what is the y value at the hole? You plug in the 9 into the problem. 9 plus 1 over 9 minus 7 over 9 minus 1. That's going to be 10 over 2 times 8. That's 10 over 16. Or 5 over 8. Okay. Next problem over here, we had a hole at 3. We're going to plug in 3 to the problem. 9 minus 3 minus 9 over 3 minus 7 and 3 plus 4. That's negative 6 over negative 4 times 7, which is negative 6 over negative 28, which reduces to 3 over 14. And that's our y value. That's where the hole is. Now, just to show this one more time. Oh, darn it. Oops, did we mess up there? I hope not. Oh, shoot. I think I plugged in the wrong number. I plugged in the wrong number. Okay. So I want to do one more thing here. Oops. You can rewind on YouTube and show I made a mistake there. I'm going to graph this original problem, and this is the last thing we'll do today. X minus 7, X plus 3, X minus 9, darn it, this didn't even come out. X plus 3, gosh, X minus 7. No, I'm going to just type in the reduced version. X minus 9. Divide that by X minus 7. And X minus 4. Okay, we said we had vertical asymptotes at -4 and we have vertical asymptotes at -4 and positive 7. Positive 7, -4. What? Oh, I freaking copied it wrong. Come on. That's a plus. You can see we have vertical asymptotes at 7 and -4. Horizontal asymptote, since they have the same speed across, is going to be at, wait, no, the bottom was bigger, right? Shoot, the bottom was bigger. At 0, we have a hole at -3 6/5. So I'm going to go ahead and show you guys this. At -3, go to -3, and 6/5 is just above here. Let's find the hole. Come on, buddy. What? Oh, right. Because our hole is at X plus 3. And now if we look at it again, the hole is, come on, undefined. That's where our hole is, right? And the hole should have been 6/5 is 1.2. And we can take a look at that again. If I delete this, we end up with 1.2 at -3. -3 should have been at 1.2. Whatever. It's there, 1.2, right? Okay, so that's your IXL. It shouldn't take you that long. The whole goal is to be able to recognize where the roots are and then how to calculate the roots. All right? So thank you very much. That's it.